Hey guys, it's nice to see you again. Today we are going to discuss another topic, and it's all about the introduction to circular functions. And our learning competency is we are going to illustrate the different circular functions. And of course, before that, let us first discuss the concept on unit circle. When you say unit circle, it is said to be a circle with a radius of 1 unit, and it is usually centered at the origin on a coordinate plane, as you observe on our diagram here. Okay? Let us show the angles included in the unit circle in terms of degrees. Let us find out the different multiples of 30 degrees, then of course the 45 degrees. Let's start with the 30 degrees. 30 degrees, 60 degrees, 90 degrees. We have 120 degrees. We have 150 degrees, 180 degrees. We have 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees, and of course 360 degrees, that inclusive of our 1 revolution. Now how about the multiples of 45 degrees? Okay, we have 45 degrees, then we have 135 degrees, and of course the 225 degrees, and lastly we have 315 degrees. Now after the angles included in terms of degrees, let us now determine the angles included in terms of radians. Let's start with the multiples of pi over 6. We have pi over 6, then of course followed by pi over 3. We have pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and of course we have 2 pi. Of course you could compute that or check that by converting our degree measurement to a radian measurement. Now let's have the multiples of pi over 4. We have pi over 4, 3 pi over 4, 5 pi over 4, and of course we have the 7 pi over 4. So after determining the different angles included in our unit circle, let us now determine the coordinates of the unit circle, starting with, of course, with the axis. Okay, of course we have here 1, 0, 0, 1, negative 1, 0, and we have 0, negative 1. Now the question is, how can we find the coordinates at 30 degrees and 40 degrees? Or 45 degrees, should I say. Okay, so let us determine how do we know the different coordinates of that. Okay, let us pick a point on the circle. We'll choose a point where the x is said to be 1/2. If the x is 1/2, what will be the value of y? Okay, so there you have. Then of course, we all know that our r there is 1 because it is said to be in the unit circle. You can see there are two y values. They can be found by putting 1/2 into the equation for x and solving for y. Now we recall our standard form for the equation of a circle, which is x squared plus y squared equals 1. Okay, so we have already know the value of our x, which is 1/2. So substituting it from our given equation, so quantity 1/2 squared plus y squared equals 1. Then we're going to solve for the unknown, which is y squared. So simply, as we simplify 1/2 quantity squared is said to be 1/4. Then transpose that to the other side. 1 minus 1/4 is simply 3/4. Now that would be the value of y squared equals 3/4. Then we need to extract. So y therefore is positive or negative square root of 3 over 2. Okay, so that is the value now of our y. So you notice here that the coordinates, okay, we have 1/2 square root of 3 over 2. The same true on the other side, which is this one. Okay, so 1/2, then negative square root of 3 over 2. Now if we are going to draw another solution for determining the coordinates of this unit circle is through this diagram, which is of course the first one of the special triangles is the 30, 60, 90. Okay, this was being used a while ago. Of course, we have here the 1 unit for the hypotenuse, and of course for the 30-degree angle we have 1/2. Then of course the 60-degree angle opposite that is square root of 3/2. Okay, on the other hand, what if, okay, there you have it. Then of course our coordinates, which is 1/2 square root of 3/2. Then the other one special type of triangle is the 45, 45, 90. So there you have. So for the 45 degrees, they have both square root of 2/2 for the values of the sides. And then of course, determining our coordinates, therefore we have square root of 2/2 and square root of 2/2. So that is for the 45, 45, 90 degree. Okay. And of course, lastly, what if we have here the same true a while ago with the 30, 60, 90? So it's just a matter of interchanging the value of your x and y. So the coordinates of this is square root of 3/2, and then we have 1/2. Okay, so how about the others? On the other quadrants of our unit circle, how do we determine that? Okay, we all know that when we use reflections of the triangles, it is said to be symmetric. So symmetric rules. So the same true here. So what will be the difference? It's just a matter of what? The same coordinates with respect to y, but of course opposite sign with respect to x. So therefore, we have negative square root of 3/2 and of course 1/2. As you notice on quadrant 1, and then of course this is on quadrant 2. Okay. Now, next one is on the 45, 45, 90. So our coordinates there is square root of 2/2, square root of 2/2. Again, use reflections of the triangles. There you have it. So the same, and of course same coordinates with respect to y, but opposite with respect to x. So there you have negative square root of 2/2 and then square root of 2/2. So there you have it, guys. And then of course for the another angle here is of course we have the 30, 60, 90, and of course determining the reflection of that. There you have it, guys. So the same y coordinates but opposite sign of your x coordinates. We have negative 1/2 square root of 3/2. So as you notice here, guys, how did we come up with the coordinates? It's just a matter of using Pythagorean theorem and of course the special types of triangle a while ago. Now, let us determine, okay, let us complete this diagram of the unit circle. Okay, and this, you know what, guys, this is needed for us for the circular functions. Okay, so we need to be to familiarize ourselves or memorize with these coordinates of our unit circle. Okay, so for 30 degrees, we have square root of 3/2, 1/2. Okay, opposite of that on the other quadrant. And then of course, reflecting on the other quadrant again, and then of course this one. So there you have it, guys. The square root of 3/2 and 1/2. It's just a matter of changing the signs of it's either the y or your x-axis. Okay, next one is the 45 degrees. We have take note of that. Remember, when you say 45 degrees, they have both square root of 2/2, both x and y. They're equal coordinates. Okay, so again, the only difference is it's just a matter of changing the positive to negative signs. Okay, there you have it, guys. And of course, the last one is with respect to 60 degrees. We have 1/2 square root of 3/2. Okay, it's just a reflection again to the other side. For other quadrant, negative 1/2 square root of 3/2. Negative 1/2 negative square root of 3/2. And of course, 1/2 negative square root 3/2. Okay, so that is the coordinates of our unit circle. Okay, now let's have here, of course, as we introduce circular functions, we define the 6 trigonometric functions in such a way that the domain of each function is the set of angles in standard position. These angles are measured either in degrees or in radians. And of course, in our lesson, we would modify these trigonometric functions so that the domain will be real numbers rather than a set of angles. Okay, the first one here is your sine theta. The value of that is simply your y coordinate. So sine theta is equals to y. On the other hand, cosine theta is equals to x. So you notice there, the value of x is cosine, the value of your y is sine. And of course, for the tangent, it's there you have it, y over x. So these are our primary trigonometric functions. And with respect to the secondary trigo functions, it's just a reciprocal of the first one. The reciprocal of sine is simply cosecant, which is 1 over y, or the reciprocal. Then for cosine, we have secant, which is the reciprocal, which 1 over x. And of course, for tangent, the reciprocal of this is cotangent, which is x over y. Okay, guys, we have here an example. Okay, for our example, find the exact values of the 6 circular functions given theta, which is 30 degrees. Okay, so 30 degrees, as we are going to illustrate this one from the properties of the 30, 60, 90 right triangles, we obtain that the length of the legs, which is we have r, or radius, is 1 unit, and of course for the value of y is 1/2. Okay, substituting it from our equation, we have 1 square minus quantity 1/2 square. So therefore, we have there square root of 3 over 2. Okay, as we picture it out, guys, we have of course this 60-degree angle, and then of course opposite that one is our 60 degrees. So our radius here is 1 unit and our y is 1/2. So from our value a while ago, wherein we have solved it already, we have known it already a while ago. So our value of our x is simply square root of 3 over 2. Now the question is, we are asked to find the 6 trigonometric functions. Let's start with sine. So if sine theta is equals to y, the value of our y here is 1/2. So simply our value of our y, our sine is simply sine 30 degrees is 1/2. That's our answer for the first trigo function. The second one is with respect to cosine. We all know that cosine has a value of your x coordinate, so which is square root of 3 over 2. So cosine 30 degrees is simply square root of 3 over 2. And then of course, the next trigo function is tangent. Okay, so we have here the value which is y over x. So simply, you get the value of your y, which is 1/2, and then with respect to your x is square root of 3 over 2. Okay, so there you have it, guys. 1/2 all over square root of 3 over 2. And we all know, as we simplify this further, okay, that our complex fraction is that we proceed to multiplication and applying reciprocal of that. So 1/2 times 2 square root of 3. You get the reciprocal of your denominator. Then of course, we cancel the common with respect to 2. Okay, so we have here 1 over square root of 3. Do we accept it as our final answer? Not yet, because we need to rationalize, or meaning remove a radical sign on the denominator. So simply multiply both your numerator and the denominator with the square root of 3 over square root of 3. Okay, so therefore, as we simplify it further, the numerator is square root of 3, the denominator is square root of 9, which is simply 3. So tangent 30 degrees is square root of 3 over 3. So that's the third value of our trigo function. Now, let's proceed with the other secondary trigo functions. It's just a matter of getting the reciprocal of our sine. So, a while ago, sine theta is y. Okay, and therefore, for cosecant, it's just a matter of getting the reciprocal of 1 over y. So, when we get the reciprocal of 1/2 is simply what? Yes, it's 2 over 1 or 2. So cosecant 30 degrees is 2. Get the reciprocal of 1/2. Reciprocal of 1/2. Okay. And then of course, for the cosine is secant theta is 1 over x. Simply the reciprocal of our value of our x. So our second theta here is, get the reciprocal, it's 2 over square root of 3. So again, we have a radical sign, so all we need to do here, guys, is simply rationalize. So multiply both sides, or simply your numerator and denominator, with the square root of 3. Okay? Then of course, simplify it further. For the numerator, 2 times square root of 3. Then of course, for the denominator, square root of 3 times square root of 3, simply square root of 9. Simplify it further, so we have 3. So second 30 degrees is said to be 2 square root of 3 over 3. Okay, and of course, the last trigonometric function is with respect to cotangent. And this is just the reciprocal of our tangent theta. So a while ago, it's y over x. This time for cotangent, it's x over y. So simplify and of course, substitute it first. Your x is square root of 3 over 2, and with respect to y, it's 1/2. Then of course, applying your complex fraction, we simply get the reciprocal and proceed to multiplication. Okay, reciprocal of the denominator, so 2 over 1. Cancel the common with respect to 2. So square root of 3 over 1, or simply the value of our cotangent 30 degrees is simply square root of 3. Okay, so these are now the 6 trigonometric functions or value of our given angle, which is 30 degrees. Okay, so let us generalize what we have discussed today. Of course, we have introduced the unit circle as a foundation of our concept on circular functions. Okay, when you say unit circle, again, it is said to be a circle with a radius of 1 unit, and it is usually centered at the origin of a coordinate plane, and with the formula of our standard form of our equation of a circle, which is x squared plus y squared equals 1. Then of course, we have introduced already our circular functions, the 6 trigonometric functions, which we have the value of your sine is equals to y. On the other hand, the value of your cosine is with respect to x. And of course, for the value of your tangent is y over x. And of course, get the reciprocal of that. Reciprocal of sine is cosecant. Then reciprocal of cosine is secant. And of course, reciprocal of tangent is cotangent. So again, guys, we have here our simple lesson for today. And once again, hoping you have learned something today. And thank you for listening again, guys. Have a nice day and see you on the next lesson. And don't forget to subscribe in our page and like our videos. Thank you, guys.